Welcome to our deep dive video on the Tunguska Event and the many theories that have followed it. If you like learning about the world's greatest mysteries, you're in the right spot. On the morning of June 30th, 1908, in the remote wilderness of Siberia, Russia, the sky exploded. Without warning, a blinding fireball tore through the atmosphere, unleashing the most powerful explosion ever recorded in human history, flattening an entire forest, shaking the planet, and leaving behind no crater, no debris, and no clear explanation. What happened over the Tunguska River that day remains one of the greatest unsolved mysteries the world has ever known. In the early hours of a quiet summer morning, the Siberian wilderness lay almost perfectly still. Endless forests stretched beneath pale northern skies, broken only by rivers, marshland, and scattered settlements so remote they barely appeared on maps. Life here moved slowly, untouched by the industrial world, untouched by war, untouched by the accelerating pace of the 20th century. And then, without warning, the sky itself turned hostile. Just after sunrise, on a day that should have passed unnoticed, the heavens ignited. From the perspective of those who witnessed it, there was no gradual buildup, no distant rumble, no sign that something extraordinary was approaching. Instead, the sky tore open in an instant. A blinding object, brighter than the sun, cut across the atmosphere, transforming the calm morning into something violently unreal. The light was so intense that witnesses instinctively shielded their eyes, convinced the world was ending. One observer later described the sky as splitting apart, as if a seam had been ripped through it. Another said the air itself seemed to catch fire. What followed was heat, sudden, overwhelming, and impossible. People miles away felt a wave of burning air wash over them, hot enough to scorch skin and ignite fear. For a brief moment, everything froze. Birds vanished. Animals bolted. The forest seemed to hold its breath. Then came the force. A colossal blast tore through the atmosphere, unleashing an invisible hammer that struck the land with unimaginable power. The ground shook. Trees snapped. Entire sections of forest were flattened in seconds, radiating outward from a single unseen point. The shockwave raced across continents, shattering windows, knocking people to the ground, and registering on scientific instruments thousands of miles away. And then, silence. No impact crater, no smoking ruin, no obvious explanation. What remained was a devastated landscape, and a question that would haunt science for more than a century. What could unleash such destruction and leave almost nothing behind? This was not a volcanic eruption. There was no earthquake fault beneath the soil. No weapon existed that could explain the scale of what had just occurred. And in a remote corner of the world, far from laboratories and telescopes, humanity had just experienced one of the most powerful explosions in recorded history, caused by something that never even touched the ground. In the days that followed, the strangeness deepened. Night skies across distant cities began to glow with an unnatural brightness. People reported being able to read outdoors at midnight, as though the sun had forgotten to set. Something had altered the atmosphere itself, leaving behind a luminous echo that stretched far beyond Siberia. Yet despite the global reach of the phenomenon, the source of the explosion remained invisible. No fragments fell from the sky. No crater scarred the earth. No definitive answers emerged. Only questions. And as the world slowly moved on, unaware of how close it had come to catastrophe, the Tunguska mystery quietly took its place among the most unsettling events in human history. A reminder that Earth exists in a dangerous cosmic neighborhood, and that sometimes the greatest threats arrive without warning, without sound, and without leaving a trace. Long before scientists would debate theories or maps would be drawn, the truth of what happened existed only in memory, carried by the small number of people who were awake, outdoors, and looking in the right direction at the exact wrong moment. These witnesses were scattered across the Siberian taiga. Reindeer herders, hunters, traders, and railway workers separated by hundreds of miles, yet united by the same impossible sight. One of the most detailed accounts came from a man named Semyon Semyonov, who was seated outside a trading post in the settlement of Vanavara. Without warning, he saw the northern sky erupt into brilliance. What he described was not a falling object, but a vast curtain of fire spreading across the heavens. The heat struck him instantly, so intense that he believed his clothing had ignited. He was thrown from his seat by a violent blast of air, even though he was dozens of miles from the source. Further north, Evenki reindeer herders experienced something far worse. They described a roaring sound like thunder tearing through the sky, followed by a shockwave that lifted people and animals off the ground. Tents were ripped apart. Reindeer were thrown through the air. Trees collapsed as if pushed flat by a giant invisible hand. Some witnesses reported being knocked unconscious, only to awaken surrounded by fire and smoke, unsure if they were alive or dead. What makes these accounts especially unsettling is their consistency. Despite vast distances between observers, their descriptions align in chilling detail. A brilliant object moving rapidly across the sky, intense heat arriving before sound, and a delayed series of deafening explosions that followed minutes later. The blast was not a single detonation, but a sequence, like artillery fire rolling across the landscape. Hundreds of miles away, railway workers felt the ground shudder beneath their feet. Windows shattered in towns that had no idea what had just occurred. Seismic stations recorded vibrations equivalent to a moderate earthquake. Atmospheric pressure sensors across Europe registered sudden spikes, as if the planet itself had been struck. Yet no one could explain why. There had been no war, no test, no industrial accident capable of producing such force. News traveled slowly, distorted by distance and disbelief. Early reports described a meteor, a volcanic eruption, even divine punishment. Some villages refused to speak of it at all, convinced the event was an omen, and still, the most disturbing detail remained unresolved. If something had exploded with such power, strong enough to flatten forests and shake continents, where was it? There was no impact scar, no smoking crater, no fragments scattered across the land. The devastation existed, but its cause had seemingly erased itself from the world. The eyewitnesses had seen the sky burn. They had felt the heat. They had survived the shockwave. But whatever caused the explosion had vanished into thin air. And as their stories slowly reached the outside world, they sparked a question that would haunt scientists for decades. How could something so violent leave behind almost nothing at all? For nearly 2 decades after the explosion, Tunguska remained untouched by science. The region was simply too remote, too hostile, and too politically unstable. Russia descended into war, revolution, and civil collapse, and whatever had happened in the Siberian wilderness faded into rumor and forgotten headlines. But one man refused to let it go. His name was Leonid Kulik, a mineralogist working for the Soviet Academy of Sciences. While cataloging meteorite collections in the early 1920s, Kulik came across scattered reports of a massive explosion over central Siberia. The descriptions immediately caught his attention. To him, the explanation seemed obvious. A colossal iron meteorite had struck the Earth, and somewhere in the taiga lay a vast, undiscovered impact site, possibly containing thousands of tons of valuable metal. Kulik became obsessed. After years of petitioning Soviet authorities, he finally secured funding for an expedition. In the winter of 1927, nearly 19 years after the blast, Kulik set out toward the heart of Siberia with a small team, crude maps, and the help of local Evenki guides. What awaited them was one of the most brutal journeys ever undertaken in the name of science. They traveled by rail, sled, horseback, and on foot through frozen swamps and dense forest. Supplies ran low. Insects swarmed when the snow melted. Progress was painfully slow. At times, Kulik had to rely entirely on oral accounts from indigenous hunters who still regarded the blast site as cursed ground. When they finally reached the devastated region, Kulik expected to see a crater, Instead, he found something far more disturbing. Stretching across the landscape was a vast zone of destruction, unlike anything ever recorded. Millions of trees lay snapped and flattened, all pointing outward from a central point, as if pressed flat by an enormous invisible palm. The pattern extended for hundreds of square miles, radiating in every direction with eerie precision. Yet at the center, where Kulik believed the meteorite should have struck, there was nothing. No crater, no impact scar, no massive fragments of iron. Even stranger, trees near the central zone were still standing upright. They were scorched, stripped of branches, and dead, but not knocked down. They stood like blackened matchsticks, frozen in place beneath an absent explosion. Kulik was stunned. This was not the signature of a meteorite impact as it was understood at the time. An object powerful enough to flatten an entire forest should have gouged the earth open, but the ground beneath his feet was undisturbed. Over the next several years, Kulik returned again and again, leading multiple expeditions. He mapped the fallen trees in meticulous detail, confirming the symmetry of the blast pattern. He excavated strange, boggy depressions he believed were secondary craters, only to find they were natural features filled with peat and water. Despite years of searching, he never recovered a single confirmed fragment of the object. What Kulik had uncovered was not evidence, it was an absence, a devastation without debris, a blast without a body. And instead of solving the mystery, his expeditions transformed Tunguska into something far more unsettling, a phenomenon that defied every known rule of impact physics. By the time Kulik's work concluded, one thing was clear. Whatever exploded over Siberia had not struck the Earth in the way anyone expected. And if it had not hit the ground at all, then where had it released its unimaginable power? As Leonid Kulik's findings circulated through scientific circles, one realization began to take hold, and it was deeply unsettling. The Tunguska object had not struck the Earth at all. The devastation had come from above. This marked a turning point in the investigation. If no crater existed, then the energy responsible for flattening the forest must have been released in the atmosphere. But in the early 20th century, this idea was radical. Explosions happened on the ground. Impacts left scars. The sky was not supposed to be capable of this kind of destruction. Yet the evidence forced scientists to reconsider everything. Physicists began reconstructing the blast using the only clues available: the direction of fallen trees, eyewitness accounts of light and heat, and seismic readings recorded thousands of kilometers away. Slowly, a terrifying picture emerged. The object had entered Earth's atmosphere at an extraordinary speed, faster than any human-made projectile, and began to encounter resistance from the air itself. At those velocities, air does not behave like air. It becomes a wall. As the object plunged downward, the air in front of it compressed violently, heating to thousands of degrees in fractions of a second. This intense pressure built faster than the object could withstand. Instead of slowing gently or breaking apart gradually, it reached a critical threshold and failed catastrophically. The result was an airburst. In a fraction of a second, the object released nearly all of its kinetic energy in a massive mid-air detonation, several kilometers above the forest. The explosion produced a downward-moving shockwave that slammed into the ground, raced outward at supersonic speed, and flattened everything in its path. Trees were snapped like twigs. Soil was scorched. Living things were thrown through the air. Directly beneath the blast, the shockwave traveled mostly horizontally, stripping branches and bark from trees without pushing them over, explaining the eerie upright trunks Kulik had documented. Farther out, the force angled downward, knocking trees flat in a perfect radial pattern. This wasn't an impact, it was a skyborne explosion, one that rivaled the power of the largest nuclear weapons ever tested, without fireball residue, fallout, or a mushroom cloud. And suddenly, the Tunguska Event stopped being a geological mystery and became something far more alarming. Proof that Earth could be devastated by an object that never even touched its surface. But this explanation raised a new, equally disturbing question. If the object exploded in the air, where did it go afterward? If it disintegrated completely, there should have been something left behind. Dust fragments, chemical traces, anything. And if it did not fully disintegrate, then parts of it might still be hidden somewhere in the wilderness. To answer that, scientists would have to stop searching for massive craters and begin looking for something almost invisible. As we move on, the investigation would shrink from fallen forests to microscopic clues, evidence so small it had been overlooked for decades, yet powerful enough to finally reveal what exploded over Tunguska. Once scientists accepted that the Tunguska object had detonated in the air, the search strategy changed completely. If there was no crater and no large debris, then whatever remained had to be tiny, so small it had blended into the forest floor for decades. The next phase of the investigation would not be led by explorers with shovels, but by researchers with microscopes. The breakthrough came in the middle of the 20th century, when Soviet scientists returned to the blast zone with a new goal: collecting soil, peat, and tree resin from across the devastated area. These samples were taken from different distances along the predicted flight path of the object, carefully catalogued, and transported back to laboratories thousands of kilometers away. What they found was subtle, but extraordinary. Embedded within the soil were microscopic spherical particles, many no wider than a human hair. Some were glassy, others metallic, and many showed signs of having been melted at extreme temperatures before rapidly cooling. Even more intriguing, similar particles were discovered trapped inside the hardened resin of surviving trees, meaning they had been falling through the air at the exact moment of the explosion. These spheres were not typical volcanic ash, nor were they products of lightning strikes or forest fires. Chemical analysis revealed something far more telling: an unusually high concentration of nickel relative to iron. This specific ratio is extremely rare in terrestrial material, but common in objects that originate beyond Earth. Further testing uncovered elevated levels of iridium in the soil, a dense element scarce in Earth's crust, but abundant in asteroids. The distribution of these elements was not random. Concentrations increased closer to the epicenter and aligned with the reconstructed trajectory of the incoming object. This was not circumstantial evidence. It was chemical fingerprinting. The Tunguska explosion had left behind a trail, not of rocks, but of dust. The object had been pulverized in the air, its remains scattered across the forest as microscopic debris, invisible to early expeditions, but undeniable under modern analysis. Still, the mystery was not fully solved. These particles confirmed that something extraterrestrial had exploded over Siberia, but they did not reveal its exact nature. Was it solid rock? Was it metal-rich? Or was it something more fragile that simply mimicked asteroid chemistry under extreme heat? And there was another complication. Eyewitnesses had tracked the object across the sky for an unusually long distance, far longer than some models suggested a fragile body could survive in the atmosphere. That raised a new possibility, one that would divide scientists for decades. What if Tunguska was not caused by an asteroid at all? As the microscopic evidence mounted, the asteroid theory gained strength. But it was not uncontested. For decades, another explanation loomed just as compelling, offering answers to details the asteroid model struggled to fully explain. This competing idea suggested that Tunguska was not caused by rock or metal at all, but by something far more fragile and elusive: a comet. The comet hypothesis emerged in the early 20th century, when astronomers began reconsidering the strange atmospheric effects reported after the explosion. Across Europe and Asia, nights glowed with an unnatural brightness. The sky shimmered long after sunset, allowing people hundreds of kilometers away to read newspapers outdoors at midnight. These luminous nights persisted for several days, unlike anything caused by known volcanic eruptions or weather patterns. Supporters of the comet theory argued that this glow was the key. Comets are not solid monoliths. They are mixtures of ice, frozen gases, and dust, often described as dirty snowballs. If a comet entered Earth's atmosphere at high speed, its icy core would rapidly vaporize, releasing enormous energy in an aerial explosion while dispersing fine particles high into the atmosphere. Those particles, reflecting sunlight far beyond the horizon, could explain the glowing skies that followed Tunguska. The theory also offered an elegant explanation for the missing crater. A body made largely of ice would not survive impact. It would explode and evaporate completely, leaving behind little more than atmospheric debris and microscopic residue. For many years, this explanation dominated scientific discussion. However, as models improved, cracks began to appear. Calculations showed that an object composed primarily of ice would begin disintegrating much earlier during atmospheric entry. Based on eyewitness accounts, the Tunguska object traveled hundreds of kilometers through the atmosphere before detonating. A fragile cometary body should not have survived that long without breaking apart prematurely. To resolve this contradiction, scientists proposed a compromise, the extinct comet hypothesis. According to this idea, the Tunguska object may have once been a comet, but after countless passes near the sun, it had lost most of its volatile ice. What remained was a dense, rocky core, coated in dust, strong enough to penetrate deep into the atmosphere, yet still capable of releasing fine particles that produced the luminous nights. This hybrid explanation kept the comet theory alive, but it raised a new problem. If the object were cometary in origin, scientists would expect to find chemical signatures consistent with icy material and volatile compounds. Instead, the microscopic debris recovered from Tunguska consistently pointed toward mineral compositions typical of asteroids. The debate had reached a critical point. Was Tunguska the explosion of a rocky intruder from the asteroid belt, or the dying breath of a long-dead comet from the outer solar system? As evidence accumulated, the scientific community began leaning in one direction. But before consensus could fully settle, the mystery took an unexpected turn, one that invited ideas far stranger than comets or asteroids. Next, we step beyond conventional science into the most controversial theories ever proposed to explain Tunguska. Ideas involving exotic physics, unimaginable energies, and explanations that stretch the limits of belief. As conventional explanations struggled to account for every strange detail, Tunguska began to attract theories that pushed far beyond mainstream science. When an event leaves devastation without a crater, fragments without a source, and witnesses describing the sky tearing itself apart, the door opens to ideas that would normally be dismissed outright. Tunguska became a rare case where even the most radical hypotheses were briefly entertained, not because they were likely, but because the mystery demanded that nothing be ignored. One of the most audacious proposals emerged during the early 1970s, when physicists suggested the blast may have been caused by a primordial black hole. These hypothetical remnants from the birth of the universe would be incredibly small, yet immensely massive. The idea was that such an object passed straight through Earth, compressing the atmosphere ahead of it and releasing energy in a violent shockwave. In theory, this could explain the lack of impact debris. In practice, it failed almost every test. A black hole passing through the planet would have produced detectable seismic signatures on the opposite side of Earth, signals that were never observed. Another proposal arose during the Cold War, shaped by fears of nuclear annihilation. Some speculated that Tunguska was caused by antimatter. When antimatter comes into contact with normal matter, it annihilates completely, converting mass directly into energy. A small amount could theoretically produce an explosion rivaling Tunguska, but this idea collapsed under scrutiny. Such an event would have left behind distinct radiation signatures, particularly an increase in radiocarbon levels. Tree ring analysis from the period showed no such anomaly. Then came the theories that blurred the line between science and science fiction. One Soviet researcher, after years studying the blast zone, proposed that Tunguska was the result of an extraterrestrial spacecraft. In this scenario, a malfunctioning alien vessel detonated its propulsion system to avoid crashing into Earth's surface. While imaginative, the theory relied entirely on speculation and offered no testable evidence. It also failed to explain the chemical markers found in soil samples. Even Nikola Tesla was drawn into the mystery long after his death. Some claimed that experimental wireless energy transmissions from his tower in New York somehow triggered the explosion across the planet. The idea ignores basic physics. Energy cannot be transferred with such precision or intensity across half the globe without loss. And no historical records support such a test occurring at the time. These theories endured not because they were credible, but because Tunguska existed in a narrow window between ignorance and understanding. It was powerful enough to inspire awe, yet poorly documented enough to invite fantasy. As scientific tools improved, each of these explanations fell away, one by one. None could account for the totality of evidence: the blast pattern, atmospheric effects, microscopic debris, and eyewitness timelines. By the end of the 20th century, the mystery had narrowed dramatically. But just as scientists felt they were closing in on the truth, a final twist emerged, one that suggested Tunguska might not have ended in Siberia at all. By the time the wild theories had fallen away, Tunguska stood not as an unsolved mystery, but as a warning carved into history. The evidence pointed overwhelmingly toward a natural cosmic intruder, yet the final shape of the event revealed something even more unsettling. Tunguska was not just an explosion. It was a near miss of planetary significance. Modern simulations introduced a chilling possibility known as the grazing impact hypothesis. According to this model, the object may have entered Earth's atmosphere at an extremely shallow angle, exploding midair, while a surviving fragment, or even the entire core, continued onward, escaping back into space. If true, this would explain the long atmospheric path observed by witnesses and the absence of large debris. Earth, in this scenario, was brushed rather than struck, spared by mere degrees. Whether the object fully disintegrated or partially escaped, one truth remains unchanged. Tunguska demonstrated that an explosion equivalent to a large thermonuclear weapon can occur without warning, without impact, and without leaving a crater behind. The forest absorbed the message in silence, but the planet did not forget. The legacy of Tunguska reshaped scientific priorities. It marked the moment humanity understood the cosmic threats are not relics of the distant past. This realization laid the foundation for modern planetary defense programs, including global efforts to track near-Earth objects and model atmospheric airbursts. Tunguska transformed abstract risk into measurable reality. That lesson returned with urgency more than a century later, when a smaller asteroid exploded over Chelyabinsk in the early 21st century. Though far less powerful, it validated Tunguska's lessons in real time, injuring civilians and shattering windows across an entire city. The skies had delivered a reminder. Tunguska was not unique, only quiet. Today, the Siberian taiga has reclaimed much of the scar left behind. New trees rise where old ones were flattened, concealing the blast pattern beneath a living canopy. But beneath the soil, the microscopic debris remains, silent witnesses to a morning when Earth crossed paths with something vast and indifferent. The Tunguska Event endures not because it defied explanation, but because it revealed something deeply unsettling: that humanity exists in a universe where destruction can arrive without warning, and survival can hinge on chance alone. The greatest explosion in recorded history did not announce itself with fire or impact, but with absence. No crater, no body, no second chance. And somewhere beyond our atmosphere, the same skies remain, unchanged, watchful, and full of wandering shadows. The question is no longer what happened over Tunguska. The question is when it will happen again, and whether next time we will be ready.